Hello everyone, welcome back to another part of the Shanghai Tower Grasshopper tutorial. I hope this part we're gonna make it short, since the only thing we want to cover in this part before we move on to the crown, which is at the top, is going to make the infills or the gap between each floor so that we can cover that up as a surface, and then you can either give it a in the end, give it a extrude, give it a small thickness so that you can render that out, or you leave it as a surface or however you want to do with it. So with that out of the way, let's start looking at where we left off. In the previous part, we did the base profile, tower outlines, and then finally got our surfaces for every general panel, everything below the crown, basically below the very top. So this is the only thing we need to, I don't know where my there we go, we're back. So we're focusing on here on the bottom floor because it's the most easiest. Now, if you look at the blue outline and if this distracts you, you can obviously turn that off in the tower outlines, which is here. So we're just gonna do that for now. We'll turn off the core also, we don't need that. And as you can see, I already turned off the surface floor, so we just basically turn everything off. All right, so let's start getting ourselves some parameters to start with. Firstly, what we want is obviously the curve that we have. So we might want to go back in here and make those accessible from the general panel surfaces group. Let's see, we definitely want the outline, so we're going to start identifying where are the outlines. It's not definitely not that one. It starts from I think this one. Yeah, okay, so this one is one of the outlines of the top panel. So we can actually come in here and say, let's do a curve, or actually, let's do a merge. We might have to switch to entwine, but we'll see about that later on. So we'll connect that here first. So we got that. I need the small one and the big one. I believe there's somewhere. I mean, if I select that, it comes from this. It should be this one of these. I think it's yes, it's definitely the top one because it's a smaller curve. Remember that we extrude down, so we need the top one. So I'll plug that in here. The data trees are a bit wonky at the moment, so we can quickly actually fix that. Right now, we graphed it and simplify it so that they're all on the one branch where possible. So if I look at D, there's only one branch. If I look at D2, it's the same thing. So when you merge them together, they fit nicely well. We're going to test that later on our theory with a branch select so that we can be sure that we're actually taking the right curves. So for this one, I think it's not that one. So it's the other one which comes from here. So we'll select that one. We'll plug it into D3. Same exercise. We're going to graft and simplify. There we go. Well, one of the branches have an extra element, so we might have to call that off. Because if I spacebar and then do a param viewer to view the tree, so branch 0 has 3 items. If I scroll all the way to the bottom, at a certain point, the item starts to diverge, which I think, if I look at this closely, it's the top one, D1. So because D1 only has 120 branches, while all the others have 127. So, I see. This is the culling where it excluded the crown floor. So if I quickly move all the way up to the crown floor and enable this one, this is where it stops. While all the other ones, it goes beyond that. So I think in the end we might have to call this off. I think better yet, we can do it right now actually. So we'll just do it like this. Surface. We'll take, let's take this one instead, the full version. So we'll call this top outline curve, top outlines. We'll just call this mid because it's in the middle. So I'll just quickly do a copy. I'll make another one, and that one should now come from this one. So we'll just copy this over here, and then we'll call this top outline start. Oh no, I accidentally copied the whole group. Now we have to wait for that 10-second. Okay, that's a mistake. Should have probably ungrouped this first before we, yeah, it's not gonna work. So let's Control Z. I'll quickly delete the group to make sure that I don't make the same mistake again. So I'm just gonna delete these again because we know that's not gonna be working for us anymore. But now I'm losing. No, I still have it. So I'm just gonna call this top. Oh, give me back the name. I'll call this end. So we got those three. And now we want the bottom three, so we need to go identify them. The bottom three came from a move, so I believe I moved it here somewhere. Well, I can move. I don't think I've moved it yet. The reason why we want the bottom three is we want all the curves to be on the same floor, and then we just simply do a curve join. After the curve join, because let me try to draw it. It's a little bit late to draw that now because I've already done that part, but better late than never. So we want all these curves, right? Go all the way around, go all the way around. And what we want now is for this curve, right? This one go all the way around too. And coincidentally, remember, it joins here. So when at the end of the day, when we have all these curves, all we got to do is just make them into one branch, and then we say close that gap, basically, and then you have your closed curve. And what you can do with that is you simply apply a boundary surface, and then you have your gap. So that's the idea of what we're trying to do here. Hence me trying to pick out the geometries or the curves that we need. So to continue on, I think I might have to do a move. So I'm just going to move that, and that one is, I'm just going to move this one down so that I can have the bottom curve, right? So I'm just going to copy this one. I'm just going to come in here and tell this, give it a name. I don't need to graft and flatten, simplify that, so I'm just going to get rid of those. I can do that on the other end where I'm going to be using these components. So, okay, and then we got, you know what, OCD kills me, so let's start mid-end, so that's better. So we got this one, we might as well just do that one instead. The start is on the other side, so I think, well, the start is on the other side. Where is it? Oh, this one. I think it's this one. Yeah, it's exactly that one. So we're just gonna take this, we'll plug it into here, and then we'll call this start. And we'll quickly copy that, and then this one comes from, I believe, this one. Yes, the shorter version. So just gonna quickly plug it in here. We'll flatten it just to make sure that it aligns with the rest of the geometry. So if you select that, you'll see that it makes a full round circle. If you select the other ones, you'll see that we have all the lines selected except for that part, which we can easily fix. Okay. So with that being done, what we can do is, before we regroup this, let's do this, the exercise that we've been doing, and create a copy of that so that we can use that in a separate group. We might have to come in here and do all this. An investment of our time to make sure that our script is readable and not a messy line of spaghetti basically in the end. So I'm just gonna move that around here. I can hide that, and then I can come in here and regroup that again. All right, now that we have this part, let's do like this. One other way we can do it now is come in here and make a merge. I believe they all, let's see, let's have a look at the data structure. Okay, I might have to graph these. Yep. So if I graph everything, yeah, looking at the final result on the data branches, it's safe to say that we also have to graph and simplify to make sure that everyone is on the same branch when they get plugged into the input, so that they can match accordingly, so that they will form the same group. Oh wait, I don't have to do 7. I don't know why I did 7. So I can actually hide that now, and then so you can see we've selected everything except for the small part. But let's do a tree branch select, and to confirm, so if I just do 5, a random number, they should select all of it on one floor, which I can already see that something it's not going entirely the way that we want to. Okay, so I think that we might, somewhere along the way, we might have to, so this is 127. Oh, one of them is now, wait, one of them is flattened. This one is flattened. Yeah, so we might have to do a shifting, because if you look at these curves, one of them is not right. So if I go back to the very first one, I can already see that this curve, actually we can call it, there's a slight sort of inconsistency in this thing. So we don't want the most bottom curve. So I think it's these that we can call. So what I'm going to do is just do a call index. Yes, we're going to do a call index. And then let me see. Then we can come in here. We'll take that. We'll say call index 0, so that you can get rid of the, wait, bottom star. Oh, bottom star is that one, which is why I don't see it. So we call that one. We're gonna plug into there. We're gonna do the same for the other 2 bottoms. And I think at the top we might have to do the same thing and call off the other one. They seem a little bit tedious to my liking, to be honest. Let me see. Because at the top, we know that at the top of this, we are going to be using a different method to do the crown. But now I'm actually thinking, is there a way for us to fix all this? I mean, this is a very easy way to do this, basically. It's just call off the top or the end, because at the top here, we don't need the top. The top doesn't form any gap. While this one, it might, well, actually, we might end up cutting off the whole crown floor. We just want this one. But since we're already here, and these components are quite easy to produce, we can actually just call them off like that. Actually, I could do a shiftless, but anyway, we'll leave it like this. We don't need to call the top. And the reason why we don't need to call the top now is because we'll be eliminating that part, right? So the important thing is that the start from this one is correct, as you can see here. So if I, for example, move this to 10, that's still correct. Now, what we want to do actually is when we go all the way to the top, to this one, this where the white panels end, this is the last of our surfaces. So instead of taking all these trees, right? So if I do a param viewer, for example, you will see that the last, I would say 7 or 8 items, it's going to have 3 elements, or the last item. Oh yeah, because it still goes on. Okay. But nevertheless, we're going to call off the top 8, or how many crown floors we have, which we can now use. Let's see. We'll take the floor, and we will also take this one. Yeah. Oh, well, I should probably undo this. Oh, the floor's not even used here. Oh, interesting. Hmm, that is interesting. Well, in that case, I'll just take this away. I'll just do a Control X, and I'll use it here instead. If that's not even used in that case. But the crown floor is used. So I'm just going to do a normal Control C and Control Shift V here, and to confirm that these go all the way back to these two. Okay. Now, as I mentioned, we don't want the top part. So one easy way to do that is you can copy these culling and then apply it to the top ones, but you still end up with a few that you don't need. We don't want all the top floors. We're going to remake that separately in a different part of the code, which will be solely focusing on the crown, right? So for this one, what we're going to do is we'll hide this one. We will create a tree masking, a tree split basically, to remove it. A tree split, which is this one, split tree, it's basically like your culling, except that instead of applying an index, you apply a mask. And a mask is nothing but the branch structure. For example, the very first number, the curly brace brackets 0, 1. If you apply that, whatever you apply is going to be masked out or masked in. But we'll see about that. It's one of them goes to the positive, which is the P, and the other one goes to the negative. So it's like your culling and dispatch in that sense. So in order to get what we want is we want to remove like the top 8. One easy way to do that is if we do a series. It can start with 0, that's fine. Still, maybe we don't need the floors here at all, but we do need the 8 so that we can have these numbers, right? Now these numbers signify if you make that into a branch. For example, if I just do path construct, is that what it is? Construct path, what you get. Oh, obviously we need to graph this because we want them in their own separate element, and then later on you can actually flatten that part. But we don't want to get rid of the bottom 8 items. We want to get rid of the top 8. So one easy way to do that is if we can reverse this in a way. So what we can do here is we can make the path start at the top, and now I'm starting to see that we can actually still use the floor by doing a subtraction. So we're going to say the amount of floor subtracted by that, and that's just where you start. And then we can apply this to the mask. And since our tree ends at 1, 2, 6, so we might have to do here one less item. Let's try that. X minus x minus 1. So we get 7 items. If we apply that here, we delete that. Yeah, so whatever you put on the mask is what you will show. So in the end, we want the negative value of this. So if we just put in a geometry up in this one, and disable that one, you will see that we have everything we need. And then we apply this here, and let's say 10, everything will be on their own floor. And once we do a boundary, oh, we need to close the curve first, so we don't do a connect curves. We're going to be focusing on this one. Before we do the connect, one thing we need to do before that is we need to join our curves, because now it's connecting in a weird way, as you can see on the model. So we're going to do a join for that curve, and then we do a connect. But default, the connect has a weird, it connects as a bulge or as tangency, I believe, as curvature. So all you need to do is right click on the G and do position. What that will do is will maintain the position and just create a straight line. So now if you plug that in, you should see they are all closed polylines. Well, you don't see it here, but if you do, I think, closed, and C will be true if the curves are closed, and these are all true values. So that's like a check you can do if you're not too sure. And now we can finally do our surface. There we go. Everything is closed. Even where it sort of like goes under, and then it's at a certain point it crosses to a point and then switches the other way around. Luckily, our boundary surface doesn't matter, doesn't care too much about that. So then if you go all the way to the top, you will see that we, in fact, have everything closed off. Now, we might want to remove this port, but we'll set that for another, when we really get to the crown. So this part is actually done. It's quite small. I think I've been talking a little bit too much. That still make this into a very long video for something that's very small piece of the whole script. I'm going to call this general panel gap infills. Does that make sense? Something that is descriptive that makes sense for you. Or general gap infills. It's not panels, is it? Gap infills, something like that. And then we'll just Control G and make that into, Control save that file again. And that should be the gap infills. Now in the next part, what we've done, to recap a little bit, is we've basically finished everything that's below the observation deck, which the crown. In the next few parts, I hope we don't have a lot more. We will focus on the crown and how we can make that, build that parametrically up. That's controlled by our parameters that we set in here. So that's going to be exciting. And with that, I'm ending this part of the video, and hope you learned something new from this, even though it's just a short one, not a lot of components. Maybe this one was interesting to know. In any case, I'll see you in the next one.